Welcome to the video on coincident, parallel, intersecting, and skew lines. First, we'll talk about the different types of lines. So coincident lines are the same lines and they share every single point. So that's what's shown here in the first picture. It looks like only one line because the two lines form the same line. Parallel lines are two lines that are always the same distance from each other, so they will never intersect. So this is what parallel lines look like. Intersecting lines are lines that share one point. So these lines have the same point right here, and so that's why they're intersecting lines. Skew lines are two lines that never intersect, but they aren't parallel. So you can only have skew lines in 3D. So in this picture, it might look like they intersect down here, but this line here, this top line, is actually up higher than the bottom one. That's why they've got this mark here showing the distance. And that's why they'll never actually intersect with each other. So they're called skew lines. So next we'll learn about points of intersection. So a point of intersection is a point that's a solution to both lines. So from the parametric equation, you would set x1 equal to x2 to get an expression for one of the variables. Then you would set y1 equal to y2 and substitute in the previous expression to solve for your first variable. And then you'll solve for your other variable and check to see if z1 equals z2. And then you can plug those variables in for your x1, y1, and z1 equations, or x2, y2, and z2 to figure out your coordinate where they intersect. So here we have an example. We'll start by setting x1 equal to x2. So this is our first step. So we have -4 plus t equals 1 minus s. So we'll solve for t by adding 4 to each side. So we get that t equals 5 minus s. Step 2 is setting y1 equal to y2. So we have 8 minus 2t equals 8 minus 3s. We'll subtract 8 from both sides. So we have -2t equals -3s. So we'll plug this in for t to solve for s. So we have -2 times 5 minus s equals -3s. We'll distribute the -2 in to get that -10 plus 2s equals -3s. Then we subtract 2s from each side to get that -10 equals -5s. And then we divide by -5. So we get that 2 equals s. So now we've solved the one variable. Step 3 says solve for both variables. So we know that s equals 2. So if we go back to this equation here, we have t equals 5 minus s, and s is 2. So t equals 3. So we've solved for both variables. We have 2 equals s and 3 equals t. So we'll plug that in for our z1 equals z2. So z1 equals z2 is 1 plus 2t equals 5 plus 1s, so 5 plus s. 1 plus 2 times t is 3, equals 5 plus s, which is 2. So 1 plus 6 equals 7, 7 equals 7. So that is true, so we know that they intersect, and we need to figure out our x, y, and z coordinates. So we'll use x1, y1, and z1. x1 is -4 plus t, y1 is 8 minus 2t, and z is 1 plus 2t. We'll plug in 3 for t. So we have -4 plus 3, which equals -1. We have 8 minus 2 times 3, which is 8 minus 6, which equals 2. And then we have 1 plus 2 times 3, which is 1 plus 6, which equals 7. So our solution is 1, 2, 7. So that's our point of intersection. Next, we have how to figure out which type of lines we get when we have two lines. So you need it in your parametric form. First, you can test if the lines have the same slope using your slope of your x, y, and z of each line. So you have line 1 and 2. So this would be, for our example up here, our slope of our first line, so 1 over our slope of our second line, x value, -1, equals our slope in our y equation, so -1 over our slope in our other y equation, plus 2, equals our slope in our z equation, 5, over our slope in our final z equation, negative 2. So negative 1 equals negative 1/2 equals negative 5/2. That's not true, so we're going to go down the line for no. If it was true, we would see if x1 equals x2 simplifies to just our variable t equaling our variable s. If it did, they would be coincident. If it didn't, then they would just be parallel lines. So now we're going to move to this step here. So we'll clear all the writing so that we have room to go over this step. So now we have this step because our answer was no to the first question. So we're going to set x1 equal to x2. So 2 plus 1t equals 1 minus s. And we need to get an expression for one of the variables. So let's solve for t by subtracting 2 from each side. So we get that t equals negative 1 minus s. Next, we need to set y1 equal to y2. So 3 minus t equals 3 plus 2s. And we're going to substitute in the previous expression so that we can solve for one variable. So we're going to substitute in for negative t. We're going to have negative 1 minus s equals 3 plus 2s. So now we can solve for s. So 3 plus 1 plus s equals 3 plus 2s. So this is 4 plus s equals 3 plus 2s. We'll subtract 1s from each side. So this becomes just s. And we'll subtract 3 from each side. So we get s equals 1. Next, it says to solve for both variables. So t equals negative 1 minus s, which was 1. So t equals negative 2. And we'll plug that into z1 equals z2 to see if that's true. So we'll do this up here in the top corner. So we have 1 plus 5t equals 1 minus 2s. So 1 plus 5 times negative 2 equals 1 minus 2 times 1. So this is 1 minus 10 equals 1 minus 2. Negative 9 equals negative 1. That's not true, so these are skew. If it was true, they'd be intersecting. So our answer for this would be skew. So now we have our first IB practice question. It says, are the following lines coincident, parallel, intersecting, or skew? So this is in the parametric form, but this is in Cartesian form, so we need to convert it to parametric. So we can use any variable we want, so I'll just use k. So we'll say x2 minus 2 over 1 equals k, and then we want to solve for x2. So we'll multiply by 1 and then add 2. So we get x2 equals k plus 2. Now we have y2 plus 6 over 3 equals k. We'll multiply by 3 and subtract 6. So we have y2 equals 3k minus 6. Finally, we have z2 plus 1 over negative 2 equals k. We'll multiply by negative 2 and then subtract 1. So z2 equals negative 2k minus 1. So now we have our line 1 and line 2 in parametric form. We'll start by seeing if they're parallel. So we'll take our slope of our x1, which is just 1, over our slope of x2, which is also 1, equals slope of y1, negative 1, over slope of y2, 3, equals slope of z1, which is 4, over slope of z2, which is negative 2. So this is 1 equals negative 1/3 equals negative 2. Those are not equal, so it's not going to be parallel and it's not going to be coincident. So now we need to see if it's intersecting or skew. So we'll start by setting our x1s equal to each other. So we get t equals k plus 2. This is already solved for t, so we can move to our second step, which is setting our y's equal to each other. We have 2 minus t equals 3k minus 6. We'll plug in our t, so we have 2 minus k plus 2 equals 3k minus 6. 2 minus k minus 2 equals 3k minus 6. 2 minus 2 is 0. We'll subtract 3k from both sides, so we get negative 4k equals negative 6. and then we'll divide by -4 to get that k equals 3/2. We can now find t because t equals k plus 2, so this would be 7/2. So now we'll check with z1 equals z2. So 3 plus 4t equals -2k minus 1. So 3 plus 4 times t, which is 7/2, equals -2k, which is 3/2, minus 1. This simplifies to 2 and 1, and this simplifies to 1 and 1. So we get 3 plus 2 times 7, which is 14, equals -3 minus 1. So we have 17 equals -4, which is not true. So they're not intersecting, they're going to be skew. The lines are skew. Now we have our second IB practice question. It says, find the point where the following lines intersect. So we know they're going to be intersecting, so we can go straight to our steps for that. The lines, however, are in Cartesian form, so we need to change them to parametric. We can use the variable t for this first one and k for the second. So x1 plus 6 over 3 equals t. We'll multiply by 3 and subtract 6. So x1 equals 3t minus 6. We have y1 plus 2 equals t. So we'll subtract 2 from each side to get that y1 equals t minus 2. And then we have -z1 plus 2 equals t. We'll subtract 2 and then multiply by a negative, so flip all the signs. So z1 equals -t plus 2. So here are your parametric equations for line 1. Now we'll do line 2 on the other side. So we have x2 minus 7 over 2 equals k. Multiply by 2, add 7. So x2 equals 2k plus 7. We have y2 minus 11 over 5 equals k. We'll multiply by 5 and add 11. So y2 equals 5k plus 11. Finally, z2 minus 7 over 4 equals k. So we'll multiply by 4 and add 7. So z2 equals 4k plus 7. So this here is line 2. So we're going to set x1 equal to x2. So 3t minus 6 equals 2k plus 7. We'll solve for t by adding 6. So 3t equals 2k plus 13, and then dividing by 3. So t equals 2k plus 13 over 3. Now we'll set y1 equal to y2. So t minus 2 equals 5k plus 11. We'll add 2 to both sides, so we get t equals 5k plus 13. And then we can substitute this in for t. So we get 2k plus 13 over 3 equals 5k plus 13. To solve for k, we can multiply both sides by 3. So we have 2k plus 13 equals 3 times 5k is 15k plus 3 times 13 is 39. We'll subtract 2k from each side, so we'll get that 13 equals 13k plus 39. We'll subtract 39 to get -26 equals 13k. And then when we divide by 13, we get -2 equals k. So now that we know that -2 equals k, we have t equals 2 times k, which is -2, plus 13 over 3. So this is -4 plus 13 over 3, which is 9 over 3, which equals 3. So now we have z1 equals z2. We need to test if that's true. It should be true because they're intersecting. So we have -t plus 2 equals 4k plus 7. So -t, which was 3, plus 2 equals 4 times k, which is -2, plus 7. -3 plus 2 is -1, so that has to equal 4 times negative 2, which is negative 8, plus 7, which is negative 1. So that's true. So now we just need to find our point. So it's x1 equals our x2. So we can use either equation. We'll just use x1. So it's 3t minus 6. So 3 times 3 minus 6 is 9 minus 6. So it's 3. y1 equals y2. So we'll use y1, which is t minus 2. So we have 3 minus 2, which equals 1. z1 should equal z2. So we'll use our z1, which is negative t plus 2. So we have negative 3 plus 2, which equals negative 1. So our coordinate where they intersect would be 3, 1, negative 1. So in summary, the type of lines we have are coincident lines, which are the same lines, so they share every point. Parallel lines, which are two lines that are always the same distance from each other and never intersect. Intersecting lines, which are lines that share only one point. Skew lines, which are two lines that never intersect but aren't parallel, so they only occur in 3D. And then we have points of intersection, which are the points that are the solutions to both lines. And to figure out which type of line, we have this flow chart right here, which is good to memorize so that you can use it on the test. That's all for this video. Thank you for watching.